Hello students, I am Dr. Mit C. Patel, Associate Professor in Mechanical Engineering Department, Silver Oak University. Today we discuss about our new chapter, Properties of Steam from Basic Mechanical Engineering subject. Now, first we discuss about the what is steam. So steam is the gas phase of water. If we apply the heat energy to the water, then the water gas convert after 100 degree into the vapor particle, and that vapor particle is called as steam. So by boiling or evaporation of water, water gets converted into the steam, and by cooling or we can call as a condensation of a steam converts into the water. This is a totally opposite process. If we apply the heat energy to the water, then it's called a boiling or evaporation of water, and water gets converted into the steam. And if we remove the heat from the steam, or we can say called as a condensation or cooling of the steam, then that steam is converted into again into water. So under normal condition, phase change can occur by pressure and temperature of vapor. Now we talk about the pure substance. What is pure substance? Then the pure substance is one which only have a single type of atoms. So what is pure substance? The pure substance are defined as substance that are made from the only one type of atom or only one type of molecule, that is called the pure substance. Here I will give you the certain examples of pure substance like salt, gold metal, then hydrogen gas, copper wire, sugar, diamond. So these are the certain example of the pure substance. So water is also called as a pure substance, but air is not a, because the chemical composition changes with the change in phase occur in the air. So we can call the vapor, water is a pure substance, but air is not a pure substance. Now we differentiate steam with gas. So what is the difference between steam and gas? So if we supply the heat to the water, then it gets converted into the steam. So it is the state of substance in which evaporation is not completed from its liquid states. And if I supply the heat to the water and it gets totally converted into the gaseous form, that means the evaporation state is completed. So it is the state in which there is a complete vaporization of liquid. It is a gaseous state. Second point is it does not obey Boyle's law, Charles' law and characteristic gas laws. Hence it is not a perfect gas. But gas is a perfect gas. So it obeys all the gas laws. Hence it is a perfect gas. Then third one, when the steam is cooled, it gets condensed and it remains same for the gas. It remains in the gaseous state at a moderate pressure and temperature. The specific volume of fourth point, the specific volume of steam is less compared to gases, and specific volume of gas is more compared to the steam. Now here you can see the phase change processes. Here I list out the 6 processes, the name of the process and what is the process. So first one, if I want to convert from the solid to liquid, then its process name is fusion. Then the process name is fusion and it's called as a melting process. Second one, liquid to solid. If I want to go for the liquid to solid phase, then it's also called as a fusion, but the process is called as a freezing. Same third one, solid to vapor. If I want to go for solid to vapor, that is process called the sublimation defrosting. Fourth one, vapor to solid, that is also called as a sublimation, but that is called the process is called the frosting. Fifth one is a liquid to vapor. The name of the process is evaporation, is same as the process is called the evaporation process. And sixth one is called the vapor to liquid. The process name as a condensation and the process also named as the condensation. So these 6 are the different process which convert from solid to liquid, liquid to solid, solid to vapor, vapor to solid, liquid to vapor, and vapor to liquid. Here we have already learned about the steam. What is steam? Steam we already covered in the first second slide. Steam is nothing but it is an incomplete stage of liquid. I mean complete evaporation stage of liquid. That is called steam. It means in steam, not the total particles of water is converted into the gaseous form. So when it get converted into the gaseous form, when we supply the heat energy to the water, then it gets converted into the steam form. So which type of heat? Now we discuss about the different types of heat. First one is the sensible heat, second one is the latent heat. Here we consider two things. First one is the phase, second one is the temperature. So when we talk about the sensible heat, sensible that means sense. So sensible is the energy required to change the temperature of a substance with no phase change. So when we supply the heat energy, sensible heat to the system, then there is a no change in phase, only there is a change in temperature. So the phase change is not occur, only change in the temperature. Now second type of heat, that is called latent heat. So what is latent heat? The definition of the latent heat is the energy required to change the phase of a substance with constant temperature. It means if I have a system, then I supply the latent heat to that system. So there is a change in phase. There is no change in temperature. Temperature get not increases or decreases. But that heat energy is utilized to change the phase. So in sensible heat, the temperature change, phase does not change. Same for the latent heat. Phase change, temperature does not change. That means temperature remains constant. Now here you can see that steam formation. What is steam formation? If I have water, then I apply the heat energy to that water, then the water gets converted into the steam. So here we discuss about this steam formation from the ice. So TH diagram stands for the temperature enthalpy diagram. So here you can see, I will point out here the temperature vertically and the horizontally stand for the enthalpy, and here we can add the heat in this direction. So what happened here, I consider the minus 10 degree temperature. So at minus 10 degree the ice formation occur. So here is a minus 10 degrees ice in this solid form. Then I supply the heat energy to the ice. So what happened, it's get absorb the heat, and again here you can see the temperature get increases. Here you can see the temperature get increases from minus 10 degree to 0 degree, but the phase is not changed. The phase is solid to solid. Here you can see the phase not changed. That means which kind of heat is supplied here during this process, we can consider A or A to B. So you can see we already studied in the previous slide. Here you can see, here you can see here is a change in the temperature but not change in the phase. So here I supply the heat energy is called a sensible heat. Then again at 0 degree I supply the again the heat energy is added. If I had added the heat energy at 0 degree, then what happened, the temperature is remain constant at 0 degree, but the phase will changing from solid to liquid. Then at this point I have a 0 degree solid ice, and at this point I got a 0 degree liquid form. Then again whatever heat is added during this portion is called the latent heat. Again I added a heat at 0 degree water, is converted into the 100 degree of water. That means the temperature gets changed, but the phase is from liquid to liquid. So there is no change in phase is constant. That means here whatever heat I added, that heat is called as a sensible heat. And again I supply the heat energy at 100 degree of water, then it's slightly converted into the vapor form, but there is no change in the temperature. So again I called as this is the constant temperature, and there is a change in phase from liquid to gas, so that I called as a heat supply is latent heat. So by this way I converted from solid ice to the gaseous form, that means called a steam form. Now we talk about the different types of steam. As you all know, we have a three types of steam. First one is called the wet steam. Second one is called the dry steam, dry and saturated steam. And third one is called the superheated steam. So what is wet steam? If I supply the heat energy to the water, then it's slightly converted into the steam. That portion of that steam is called the wet steam. So the mixture of steam and water is called as the wet steam. It is a first phase change, or we can call it the first phase of the water that convert into the steam. So wet steam has a dryness fraction. What is dryness fraction? That is the important term for us. So what is dryness fraction? So here I show you the equation as well as the definition of the dryness fraction. So dryness fraction is the ratio of mass of dry vapor to the mass of water vapor and dry vapor present in the wet steam, or we can call as in simple language, dryness fraction X is equal to mass of steam upon mass of steam plus mass of water. This is a very simple and basic equation. X, dryness fraction, is denoted as by X. So X is equal to mass of steam Ms upon mass of steam plus mass of water Ms plus Mw. So equation becomes X is equal to Ms upon Ms plus Mw. Now we talk about the wetness fraction. We already covered the dryness fraction. Now we talk about the wetness fraction. What is wetness fraction? It is the totally opposite of the dryness fraction. So wetness fraction is the ratio of the mass of water particles to the mass of water particles and dry vapor present in the wet steam. So wetness fraction is equal to mw upon ms plus mw, and wetness fraction we can consider as a 1 minus x. X is denoted for the dryness fraction. So for wetness fraction we can write as a 1 minus x. So we can get the value of wetness fraction. Now second stage of steam is dry and saturated steam. Here you can see that the dry and saturated steam is called as the second stage of steam. So dry and saturated steam, again I supply the heat energy to the water, it get converted to the wet steam. Again I supply the heat energy to the wet steam, it get converted into the dry and saturated steam. So dry and saturated steam results if sufficient heat after boiling point. Boiling point, that means the water boiling point of water is 100 degree. So sufficient heat after boiling point is added to the wet steam at the saturation temperature. Saturation temperature is we can get as the 100 degree with constant pressure, that is called the dry and saturated steam. So there are no moisture particle available in the dry and saturated steam. Mostly water particles get converted into the steam particles. So we cannot find any kind of moisture in dry and saturated steam. So dryness fraction is 0.90 to 0.99 for the dry and saturated steam. Dryness fraction is X. So what is the value in between for the dryness fraction for dry and saturated steam is 0.90 to 0.99 for dry and saturated steam. Now we talk about the superheated steam. So if dry and saturated steam is further heated to at constant pressure and temperature at higher than its saturation temperature, then the steam is called as a superheated steam. Again I repeat, first we have a water, I supply the heat energy to the water, it get converted into the wet steam. Again I supply the heat energy to the wet steam, it get converted into the dry and saturated steam. Again I supply the heat energy to the dry and saturated steam, then it's converted into the superheated steam. So here we talk about the superheated steam. So if dry and saturated steam is heated further at constant pressure to a constant temperature higher than its saturation temperature, the steam is known as a superheated steam. So the heat is added to a get superheated steam from dry and saturated steam is known as a heat of superheat. That means if I have a dry and saturated steam and I want a superheated steam, so what we have to do? We have to add the heat energy to the dry and saturated steam. If I add the dry and saturated heat to the dry and saturated steam, then the steam get converted into the superheated steam. Okay, so whatever heat is added to the dry and saturated steam to gets converted into the superheated steam is called a degree of superheat, or we can call as a heat of superheat. There is a two terms, degree of superheat, or we can call as a heat of superheat. So the formula of the heat of superheat and degree of superheat is CP T superheated minus T saturated. So the degree of superheat, or we can call as the heat of superheat equation, is CPS. CPS stands for the specific heat of steam at constant pressure into T superheated minus T saturated. Now we learn about certain terms. First term is the specific enthalpy of water. It stands for HF. Is nothing but it is a enthalpy, or it is a specific enthalpy. Specific, that means the per unit, that means if I have a 1 kg of water and I want to raise the temperature from 0 degree to saturation, then whatever kind of heat I want to supply, that is called the specific enthalpy of that water, HF. So the amount of heat required to raise the temperature of 1 kg of water from 0 degree to the saturation temperature at constant pressure is known as a specific enthalpy of water. Now we write down the mathematical equation. HF stands for the specific enthalpy of water, equal to CPW. What is CPW? The specific heat of water at constant pressure. The value of specific heat of water is constant, is 4.187 kilojoule per kg Kelvin into Ts minus 0. Ts stands for the saturation temperature of water, or we can consider as 100 degree, minus 0. 0 degree is when we start from the zeros, that's why 0. So we can write as HF is equal to CPW into Ts minus 0. Now we talk about the new term, specific enthalpy of evaporation. In simple language, we can write as a HFG. So what is HFG? It is a term called as a specific enthalpy of evaporation. So the amount of heat required to evaporate 1 kg of water at the saturation temperature into 1 kg of dry steam at the same temperature and pressure is called as a specific enthalpy of evaporation. Specific enthalpy of evaporation, that means in this part we have a fluid particles as well as we have a gas particles. If I write down HF, is totally depend on the fluid particles, but when we write down the HFG, stands for the some particle are fluid, some particle are, we can get a fluid, that means the liquid, and some particle are called as a gaseous form. So it denoted by the HFG, and the unit of the HFG, specific enthalpy of evaporation, is kilojoule per kg. So it should be noted here. You can show. I will write down in the red fonts. It should be noted that the enthalpy of evaporation decreases with an increase in pressure, and it increases at critical pressure. Again, I repeat, it should be noted that the enthalpy of evaporation decreases with an increases in pressure, and it's increasing at critical pressure. Now second term is called the specific enthalpy of wet steam, that is called H weight. So how can we define it? So it is defined as the total amount of heat supplied at a given constant pressure to convert 1 kg of water at 0 degree into 1 kg of wet steam at the specified dryness fraction. It is a very simple term. If I want to write down in the mathematical terms, so I can write the H is equal to HF plus XHFG. What is HF? HF is the specific enthalpy of dry steam. What is HFG? It is a specific enthalpy of dry and saturated steam. And what is X? X stands for the dryness fraction. Now second term is called the specific enthalpy of dry and saturated steam. It stands for Hg. So it is defined as the total amount of heat supplied at a given constant pressure to convert 1 kg of water into 1 kg of dry and saturated steam at its saturation temperature. Again I repeat, it is defined as the total amount of heat supplied at a given constant pressure to convert 1 kg of water into 1 kg of dry saturated steam at its saturation temperature. So now we can write down the value into mathematical forms. So Hg is equal to Hf plus Hfg. Here we can write down in mathematical term Hg is equal to Hf plus Hfg. Now we learn about the new term is the H superheated, that means the specific enthalpy of superheated steam. These all our terms are utilized in the numerical parts. So we need to learn about the basic concept of this all the terms and mathematical equation of the all the statements or all the terms. So specific enthalpy of superheated steam H superheated, any further heating of dry and saturated steam will increase the temperature of steam at a given pressure. This steam is called superheated steam. This steam is called superheated steam and its temperature is denoted by T superheated. Again I repeat, any further heating of dry and saturated steam will increase the temperature of the steam, and the temperature of the steam is increases, then the steam from dry saturated is get converted into the superheated. So this steam is called as a superheated steam and its temperature is denoted by T superheated. So superheating process is carried out in a heat transfer device called a superheater. This conversion from dry and saturated steam to superheated steam, that process is carried out in superheater. Now we write down the mathematical formulation of the superheated steam. So H superheated is equal to Hg plus Cps T super minus T saturated. H superheated is equal to Hg, that means it is the specific enthalpy of dry and saturated steam. But if we added the degree of superheat into the dry and saturated steam, then we got the superheated steam. So what is the degree of superheat or heat of superheat? We already studied in the superheated steam. The equation is Cp T super minus T saturated, that is the heat of superheat, or we can call as a degree of superheat. So if I added this degree of superheat into the dry and saturated steam, then we can get the superheated steam. So H superheated is equal to Hg plus Cps T super minus T saturated. Now we learn about the specific volume of liquid. It is a very simple, just I go through it. It is defined as the volume occupied by 1 kg of water at the saturation temperature at a given pressure is called the specific volume of liquid, and we denote it by the Vf. So the specific volume of liquid Vf is obtained from the steam table in meter cube per kg. What is steam table? We learn in the next subsequent slides. Now we talk about the specific volume of wet steam. So we denote it as a V wet. It is a very simple term. So the volume of wet steam per unit mass of a given pressure and the saturation temperature is specific volume of wet steam. So the wet steam is made with dry vapor and moisture particles. So we can write down the V wet is equal to X into Vg. X stands for the dryness fraction and Vg stands for the specific volume of gas. Now we can write down the specific volume of dry and saturated steam. So it's very simple term. It is the volume of dry and saturated steam per unit mass at a given pressure and saturation temperature is specific volume of dry and saturated steam. So if I want to find out the value of specific volume of dry and saturated steam from the steam table, so we can find the Vg is equal to 1.6937 meter cube per kg at 1 bar. So the simple equation or mathematical equation of the specific volume of dry and saturated steam is Vg is equal to Vf plus Vfg. Now same for the superheated steam. So the specific volume of superheated steam is V superheated. The volume of further increase by giving the heat energy to the dry and saturated steam at constant pressure with rise in temperature. That is called the specific volume of superheated steam. So superheated steam behaves like a perfect gas and it obeys all the gas laws. So we can write down the mathematical equation for the specific volume of superheated steam is V superheated upon T superheated is equal to V saturated upon T saturated. Again I repeat, superheated steam behaves like a perfect gas, so it obeys all the gas laws. The simple mathematical formulation is V superheated upon T superheated is equal to V saturated upon T saturated. Now these are the combined equation for the wet steam. H is equal to HF plus XHFG, V is equal to XVG and U is equal to H minus PV. So here is the equation for the enthalpy, volume and the internal energy. Same equation for the dry and saturated steam. Enthalpy H is equal to Hg, V volume is equal to Vg and internal energy U is equal to H minus PV. Same equation for the superheated steam. H enthalpy H is equal to Hg plus Cps, T superheated minus T saturated. Second equation for the volume, V superheated upon V saturated is equal to T superheated upon T saturated. If I want to V superheated, so I can make a subject of V superheated. So V superheated is equal to T superheated upon T saturated into V saturated. And the equation for the internal energy U is equal to H minus PV. So all 3 plus 3 plus 3, 9 equation. 3 equation for the wet steam, 3 equation for the dry and saturated steam and 3 equation for the superheated steam. All 9 equation are utilized during we are going for the solve the numericals. Here we discuss the short notes about the steam table. There are two types of steam table. First one is called the properties of steam based on pressure and second one is the property of steam based on temperature. So based on pressure and based on temperature we have a two table for the solving the numerical of steam. So here you can see that if I talk about the based on pressure, so first column is for the pressure, second column is the saturation temperature, third one is the Vf, Vg, Hf, Hfg, Hg, Sf, Sfg and Sg. If I talk about the based on temperature, so nothing but the column number 1 and column number 2 are interchanged. Temperature comes first and pressure comes second. So temperature, then pressure, then Vf, Vg, Hf, Hfg, Hg, Sf, Sfg and Sg. All terms are as similar as based on pressure table. There is only one change. The column number 1 and column number 2 are gets interchanged. So here I will do the certain small exercise, then we conclude our session. So here pressure P is equal to 10 bar and I want to find out the HF, HG, VF and VG. So how can I find out? Here you can see the pressure is already given. So I have to mark the pressure table, and in pressure table for in first column I have to mark as a 10 bar, and in respective column I can directly find out the HF, HG, VF and VG. Same for the second one, pressure P is equal to 25 bar. So I have to use the pressure table and I have to mark on the pressure table 25 bar, and I with respect to 25 bar pressure I have to take the value of HF, HFG, HG, VG, VF and TH from the pressure table. Same I have to do for the third and fourth one. Temperature T is equal to 30 degree. So I need to use the temperature table in place of pressure table, and respective with the temperature, first column of the temperature we can mark as a 30 degree, and from respect to the 30 degree I can take the value of HF, HG, VF and VG. Same for the 56 degree temperature, I have marked the 56 degree temperature on the temperature table first column, and with respect to 56 degree I can mark the all the values from the temperature table, HF, HFG, HG, VG, VF and pressure P. So this is a simple